Hello to you and welcome back to Mathics. Well, in this video, as you see, I'm going to go through 2023 AMC 10N problems, and it's going to be a full solution. And I would like to make a few points. So point number one is that the videos I make, you could see that they're very long, like 2 hours, 3 hours long. And the reason for that is I teach all the fundamentals you need in order to be able to answer any given question. So like if you go on AOPS website, there are a bunch of solutions. You read them, sometimes you don't understand. And the reason is that, one of the reasons is that you don't know the fundamentals, right? So I teach you everything you need before you could actually answer this problem. So that's one thing I do. So point number two, you solve a problem correctly, but sometimes you don't do it the best way possible. Maybe it takes you longer than it's supposed to. So even if you do a question that you think, well, I was a little lucky, or well, maybe I could have done it faster, then check the solution. Maybe there will be some better ways of doing it. And the point number three that I want to make, you could book lessons with me. And I have my email address here. I have my WeChat, my Telegram, and Instagram account. You could contact me in any of them. And feel free to do that. I would be really, really happy to help you to get the score that you need, and more important than that, like improve your problem solving skills and improve your math. And I would be really, really happy to do that for you. Okay, problem one. Cities A and B are 45 miles apart. Okay, Alicia lives in city A, so I'm just going to write A for Alicia. And Beth lives in B. Alicia bikes towards B at 18 miles per hour. So this goes with the speed of 18 toward B. Okay. Leaving at the same time, Beth bikes toward A at 12 miles per hour. Okay. How many miles from city A will they be when they meet? Okay. So because they go together, right, they will meet each other sooner. Okay. So that means together they will have a speed of 30 miles per hour. Okay. So after 1 hour, together they go 30. Okay. In 2 hours, they go 60. But all of this is 45. Okay. So we're going to go, it's going to be more than 1 hour, less than 2 hours. So we know it's going to be the distance, 45 miles, divided by the speed they have, okay, which is 30. So it's going to take 1.5 hours, okay? So now what do we want here? It says, okay, how many miles from city A will they meet, okay? So from here, because we want from city A, let's go from here. In 1.5 hour, how far has A gone? In 1 hour, it goes 18, right? In 1.5, it goes half of 18, which is 9. So it will be, you could write it like this, 18 plus extra 9, 27. Or you could write it like this, that a speed is 18. It's continuing with the same speed for 1.4 hour. Okay, so it's going to be 27. 27 is going to be more than half, so it's going to be 27 over here. But remember one thing, okay? If we multiply this 1.5 by 12, okay, it's going to be 18 over here. So the answer will be 18 from B, 27 from A. So, of course, the answer will be E. Okay, problem 2. The weight of a third of a large pizza. For pizza, I'm going to put P. Okay, so we're going to have a third of a pizza together with 3.5 cups of orange slices, I'm going to write this as 7/2. And for oranges, I'm going to just use R instead of O, not the first letter, because it will be mixed with 0. We don't want that. So it's got to be 7/2 R's. Okay, oranges is equal to 3/4 of a large pizza and half of R's. Okay, so what should we do now? P's on one side, R's on one side. We need to do that. Okay, so I'm just going to write it here and clean it. Okay, in case you need it. So from both sides, I'm going to minus, okay, half an R to get rid of this. Okay, and both sides, I will also minus it by 1/3 of P. Okay, so we're going to get this. I'm not going to write a lot of details. Okay, because this is like AMC 8, AMC 10. Okay, so to do that, it's going to be, when we do that, we'll have 6/2R. It's going to be like 3R is equal to, okay, 3/4 of P minus 1/3 of P. Okay, so we're going to take out P because they're common. So we're going to have 3R is equal to, okay, 3/4 minus 1/3, all of it multiplied by a P. Okay, so we're going to get again 3R is equal to, okay, 12 is 4 times 3, 3 times 3, 9, minus 4, okay, which is going to be 5/12 P. So, okay, now because we want the value of P, so I will multiply both sides by 12/5. Okay, also this side. So the reason I do this is because they will cancel, right? So what we're going to do after doing this, okay, so 1P will be 3/6/5 of R. So this P and R was not that good of an idea, right? It's a little confusing. So oranges, okay, for oranges, what we're going to have, it was saying that a cup of oranges is 1/4, okay, of a pound. So instead of oranges, we're going to get 1/4. So this 4 cancels, simplifies with this. It's going to get 9/5. So P will be 9/5, which is going to be equal to 1/4/5. So A is the right answer. Okay, problem 3. How many positive perfect squares less than 2023 are divisible by 5? Okay. So what is the smallest one, which is a square number divisible by 5? 2 squared, 3 squared, 4 squared. The first one is 5 squared, or 25. Okay. So what is the next one? So is 5 squared multiplied by 2 or 3? Is that going to be a square number? No. We need a number. We need to multiply it by another number that is also squared. So in other words, we want a number that here it has an even number. If it's odd, it's not going to be a perfect square. Okay, so 5 squared is the first one. The next one will be 5 squared multiplied by 2 squared, which is going to be, we don't need it, but it's going to be 100. The next one will be 5 squared multiplied by 3 squared. Okay, so we just have to continue like this. Okay, this one is 225. So you just have to come up with the last one. So the last one will be 5 squared multiplied by, you just make a guess and check. Okay, my guess would be, let's go with 10. If I go like 10 squared, okay, this would be 100 multiplied by 25 will be 2,500, which is way off. I'm larger. Okay, so that's not going to be it. So not a good guess. How about 9 squared? Okay, you check that. It will be 2,025. It would be slightly more than this. Okay, so the last one, the biggest one you could go with is going to be this one, 5 squared multiplied by 8 squared. You could write this as 40 squared, which is going to be 1,600. It's definitely less. Okay, so just when you want to count this one thing, the first one is started by 1. Okay, 1, 2, 3, and the last one is 8. Okay, remember this could be sometimes if you only check the last number, you see 8 number, you could make a mistake, especially if the beginning number starts with the 0 when you're counting. Okay, you always check that. The first one is 1, the last one is 8, so we have 8 numbers. Okay. Okay, problem 4. Well, if you have seen a question like this, a similar question, well, to do this, you just need 1 second to completely find the answer. Okay, let's read the question. A quadrilateral has all integer side lengths, a perimeter of 26, and one side of length 4. What is the greatest possible length of one side of this quadrilateral? Okay, now let's see here. If you have seen a question like this, you just need to divide this by 2. Okay, and once you do that, you just want to find the next integer that is a little smaller than it. So it's just 13. One integer lower than 13 is going to be 12, and that's it. But why is that? Let me explain. Now let's understand this idea using a triangle first, then we apply it to this quadrilateral as well. Okay, so now if we have 8, and 8 is larger than 5 plus 2, you see, it doesn't matter what angle we have, even if I bring this down all the way here, and if I bring this 2 over here, okay, you will see that it's not going to be enough, okay? Now if I make this one 3, however, like if the green one is 3, okay, so not 2, if this one is actually 3, right, if it's just going to be equal, even if we go with 0 degrees, okay, both of them are going to be like this. But if they are a slightly larger, like if this, for example, this one is 3.2, okay, that's going to be enough to make a triangle. Okay, but the angle at which the triangle is made is going to be small, right? It would be, if it's 3.2, it's going to be, if I can make it something, your triangle will look something like this. Okay, it's going to be a little larger. That would be your triangle. Okay, so it needs to be a little even larger than half. Okay, so let me draw a quadrilateral and we deal. So now imagine, okay, we have the perimeter of the quadrilateral is 26. Okay, and one side is 13. Okay, and it says the book that one of them is 4, like in the question. So the perimeter, what do we have? What is left? 26. Okay, it's going to be 26. It's not writing. So 26. Okay, it's working now. 26 minus 13 minus 4. Okay, it will be 9. Okay, so, and it's going to, this 9 is going to be 2 different lines. You see that this 9 will be completely on top of this. So it doesn't matter. Like if this side is like this, the other one will also fall into it with a different color, right? The sum of these two still will be 9. So this will be 9. It's not going to work. You're not going to have a quadrilateral. But because here it says it's going to be a integer side. So if 13 doesn't work, okay, so all we have to do is just make this one a little shorter. If this is 13, okay, now you have 14, okay. So if this one is 4, so let me just draw a line of 4. Okay, so what is left? We have like 10. 13 plus 4 is 17. Okay. I'm sorry, it has to be 12. Change that into 12. So if we make this 12, the sum will be 16. We have 10 left. Okay, so we could have our quadrilateral because it will be larger. Like this, it doesn't matter how you draw it. So it's possible to draw something like this. So we could make infinite shapes like this. Okay, so it doesn't matter as long as the sum of these three sides, the yellow one, the red one, and this one, okay, is more than this 12, we could make our quadrilateral. So all you had to do is just divide 26 by 2, okay? If it's going to be exactly half, it's not going to work. You go just one below the half, okay? So it will be 12, the right answer. And remember, this 4 was basically just over here to confuse you, okay? So that you think, whoa, what a difficult question. Okay, problem 5. How many digits are in the base 10 representation of this number? Okay, so to do this question, you need to know power rules. And that 10 is equal to 2 times 5, really. And 100, okay, is equal to, okay, 2 of this, right? So if you have 2 times, each 0 is equal to 1, 2 times, and 5. Okay, so you take 0, 1 0 is equal to a 2 multiplied by 5. That's all you need to do. Okay, so this one, okay, 8 we know is 2 to power of 3, again to power of 5. Okay, so this would be 2 to power of 15. Okay, you just multiply 3 by 5. Okay, and this will be 2 to power of 15 multiplied by 5 to power of 10. And 15, I'm going to write it as 5 to power of 5 multiplied by 3 to power of 5. Okay, so this is 15. Okay, so now we have these powers 5 and 5. So because the bases are the same, I'm going to add the powers. Okay, so it will be 2 to power of 15 multiplied by 5 to power of 15. Okay, and 3 to power of 5. Okay, good. So as I said at the beginning, this will create 15 zeros. Okay, and this number, we know that 3 to power of 4 is 81. This is going to be like 81 times 3. It's going to be a 3-digit number, right? It's going to be like 323. So we're going to have 3, 2, 3, 3 digits, and 15 zeros like this. Okay, so it will be a total of, okay, 18 digits. Okay, now one extra thing, right? So I know some of you will just have a little problems with power rules. Okay, so if you have, for example, this one, why is this 2 to power of 15? Okay, remember, what was power? What was the definition of power? It was multiplying a number by itself. Okay, so we have to multiply 8 5 times. Okay, it's just going to be, I could write it as 8 times 8, like this number. Let's take this one. This was 8 times 8 times, okay, 8 times 8. Okay, so we're going to repeat this, okay, 5 times. And each one, it will be like 2 to power of 3 multiplied by 2 to power of 3. And it's going to be like this. Okay, so we just, and when it's like this, you could just come up with easy examples and try them yourself, right? So, right, if you're ever confused, do I really need to add all these threes together? Okay, make an example like, you know, that, okay, So 2 to power of 3 multiply 2 to power of 2. Okay, so you know that this is 8. You know that this is 4. Okay, you know that the answer is 32. And you know that 32 is equal to 2 to power of 5. So what did we do here? We added the powers together. So if you ever forget, right, you're doing in the middle of task, it's not a good idea, but you just come up with really simple examples that you know, you apply them, you make the formula, okay, in case you forget it. Okay, so that's E. Let's do the next one. Okay, problem 6. Well, I'm pretty sure a lot of the students will waste so much time on this question, right? If you write down, like, I spent 15 minutes on this question, I would believe you. But it's actually not a very difficult question. Okay, so let's see here. An integer is assigned to each vertex of a cube. Okay, let me draw a cube very quickly. Okay, so we're gonna have a cube like this. Okay, so this question is going to be extra difficult for non-native ones like our Chinese or Asian participants because it has a lot of words that they might not know. Okay, so here is each vertex of a cube, okay? So vertex would be each point, okay? And if it's just more than one vertex, it becomes vertices, okay? So, and we're gonna just put like some numbers on each of these vertices, okay? And here it says the value of edge would be, each line will be an edge. Okay, so edge is this, the point is V, and all of this page, okay, all of this will be a face. Okay, a value of an edge is defined to be the sum of the values of the two vertices touches. Okay, so I'm going to just call this one as an example A and just put some random numbers here. These are random numbers like 2 and this one 5. Okay, so now it says, okay, the sum of the values of the two vertices touches. So this side, this one will be A plus 2, this edge. Okay, and this one, okay, will be A plus 5. Okay. And the value of the face is defined to be the sum of the values of the 4 edges surrounding it. Okay. Now, this face, all of this face, we're going to talk about this. Okay. This is a random point A. Okay. So when I want to sum these two together, okay, so you will see that I'll just have to go A plus 2 and then A plus 5. So you will see that this random one, okay, this point, okay, repeated 2 times, okay? So for this face, so now when we add this face, we're gonna have 2A, okay? And this point is also shared on this page, okay? So this will get another 2A, okay? And the one behind it, this page behind it, will get another 2A, okay? So because one vertex, one point is shared with 3 pages, 3 faces, okay? And each A is repeated 2 times, okay? So that's will make 2A multiplied by 3. So that means each point, okay, will be repeated 6 times, okay? This was A, I called it A, and I chose this one at random, right? So if this one is called B, B will be repeated 6 times. Whatever it is, it will be repeated 6 times. So each vertex will repeat it 6 times, okay? So we know that the sum of them is 21, and each one will be repeated 6 times. So we really have to go 21 times 6 is going to be 126. Okay, not very difficult. Okay, problem 7. Janet rolls a standard 6-sided die 4 times and keeps a running total of the numbers she rolls. This could be a little weird. So what's the meaning of running total of the numbers? Like she just throws the dice, okay, roll it. Maybe it's just like brings a 3. Okay, then the next time it rolls it, maybe it brings a 2. It just like keeps adding them, right? That's like the total. Running means it does it with each time that it rolls the dice, okay? What is the probability that at some point, maybe the first time, maybe the second time, maybe the third time, her running total will equal 3, okay? So I threw it, right? I rolled the dice. There's 6 possibilities. If I bring a 3, that's it, right? So from 6, if I bring a 3, that will be 1 over 6, okay, plus. So what if I bring 3 the second time, right? So the first time 6 possibilities, I throw it twice, it will be 6 squared. So how is that possible for me to get a 3, okay? Maybe the first time I get a 1, and the next time I get a 2. Maybe the first time I get a 2, the next time I get a 1. Okay. This time, if I get a 3, it's not going to be because the total would be 1 plus 3. So only 2 possibilities. Plus. So the third time I roll the dice, okay, will be 6 squared. So when we throw dice, there's no 0, is it? So the only way to get 3 is just the first time I get a 1, the second time I get a 1, and the third time I get a 1 again. So it will be like this. Is it possible to get a total of 3 with 4 roll of a dice? No. So it'll be like 0. Okay, this one was just there probably to just confuse us. Okay, so we just need to add all of these. Okay. So, okay, this one, 3 squared will be 3 cubed will be 216. This will be 36. Okay, this has been multiplied by 6, so plus 12 plus a 1. Okay, you add them all up. It becomes 49 over 216. So B is the right answer. Okay, problem 8. I think to do problem 8, if it's unclear for you, you need to graph something, sketch something. And this is exactly what we're going to do for this problem. Barb, the baker, has developed a new temperature scale for a bakery called Breadis scale, which is a linear function of the Fahrenheit scale. Why did the question have to say this? Okay. So it's just linear. It means like this, for example, inch and centimeters. Like an inch is always 2.54 centimeters. Okay. If it's not linear, for example, if it's exponential, right, between some two things, it would be like this. First 1 inch at the beginning, for example, 1 inch is 2.54. After, for example, 20 inches, this will change. For example, if it's not linear, then 1 inch could be 1.5. It could be 3. It keeps changing. But here it says the ratios are constant. That's why it's saying which is a linear function of the Fahrenheit scale. Okay, so bread rises at 110 degrees, okay, Fahrenheit, which is 0 degree on Breadis scale. Okay, so let's just go. I want to just draw two things very quickly. Okay, so up, the higher is up. Okay, so for example, this could be Fahrenheit 0. I'm not gonna make purple. Okay, so bread rises at 110 degrees Fahrenheit. Okay, so imagine this is 100. Okay, so this would be 110. Okay, this 110 will be the zero of the other one. So this is going to be like, okay, this one, for example, is B. This one is Fahrenheit. But for this one, we just call this 0. Okay, now let's continue reading. Bread is baked at 350 degrees Fahrenheit, okay, which is 100 degrees, and the bread is a scale. So we have to go 350, this is 100, 200, let me make it purple again. So this would be 200 again. We go up, this is 300 again. Okay, so this will be 350, okay? So if I continue this, okay, so this would be 100. So now we need to see one scales, okay? So we just need to know 1b is equal to how many of this, okay? So 100 was between this distance. It's 350 and 110. So I'm going to write 350 minus 110, okay, divided by this. We want to know what is, how large is this new scale, okay? So 240 divided by 100 is going to be 2.4. So this is going to be larger. 1b will be a larger scale than a Fahrenheit. So 2.4 Fahrenheit. Okay, so this is what we have. So let me do some cleaning here and read the rest of the question. So here it says bread is done when its internal temperature reaches 200 degrees Fahrenheit. Okay, so our 0 was at 110 and we need to reach this 200 right over here. Okay, so we want to know how much is that. Okay, in Fahrenheit, this is going to be 200 minus 110. Okay, which is going to be, of course, 90. Okay, so, but this 90, this distance, this 90 is in Fahrenheit. Okay, we need to divide it by 2.4 to get it in B temperature, bread is a scale. So it's going to be like this. Okay, so do this however you can. I'm going to write this as 45 divided by 1.2. Okay, so it will be 45. Okay, 5/6. So we could simplify this by 3. So it will be 75/2. So the temperature will be 37.5. It will be right over here. Okay. Well, problem 9, I think this one is not an easy one. It's a little challenging to understand and you need to be very organized when doing it. Okay, so let's do problem 9. A digital display shows the current date as an 8-digit integer consisting of a 4-digit year, for example here, 2003, this part, followed by a 2-digit month. So here is going to be the 4th month, April, followed by 2-digit date, 28th of the month. So for example, this day is in this year is displayed as this. So for how many dates in 2023 does each digit appear an even number of times in the 8-digit display for the date, right? So probably when you read it this time, if you don't understand, that's okay, I think. So nobody probably get it the first time. Just have to read it. Like each digit appear at an even number of times. So for example, right now 3 has happened once Is that an even repetition? No. So 3 has to be repeated more. Okay. So here it says this year. Okay. So let's write it down. It's going to be 2023. So this one is forced already. Okay. We just have to decide for these other 4 numbers. Okay. 2 has repeated 2 times already. Okay. So 3 needs to be repeated once and 0. Okay. So can 3 be here? Do we have, well, the maximum number for months is 12. Of course, 3 can't be here. We don't have 30 something months. Okay. So that's good. So 3 could be here, like the 3rd month. Okay. Do we have 13 months? No. So we only have 1. If 3 is here, then 0 will be forced like this. Okay. So 3 has repeated, 0 has repeated. So we need, if I put here, can I, for example, write 15 here? No, because 5 will be odd, 1 will be odd. So whatever I write, I have to repeat it. So it would be 11. Or it could be 22nd. 33 will not work, right? A month is maximum 31 days. So if it's like this, we'll have 2 repetition like this, if 3 is here. So let's just go, we're doing a casework, right? So what if 3 is in this position? So if 3 here, we could have the 30th day, or we could have 31st day, like it's going to be like here. If it's 30, so we need another 0, okay? So let's just go here. For example, if I have a 0, okay, so no, I'm sorry. So 0 has already been repeated. So 0 is okay, okay, 3 is already okay. So what months can I write here? Only the 11th, right? There is nothing else. So it will be only 1. So what if I just have 31st? Okay. So now I need another 0 and I need a 1. So it could be like the first months of the year or the 10th months of the year. So 2 more possibilities like that. Okay, let's just let them be here. Okay. So the last place will be something like this. So we'll have 2023. And so what if the 3 is in the last place? Okay. It could be the 3rd of the month, 13th of the month, 23rd of the month. Okay. If it's 0, so everything already there, we could have only the 11th month. So it will be like 1. Okay. If this is 13th, so we need another 0. Okay. And another 1. So maybe 10s again, maybe 0 and 1. Okay. So it will be 2 more possibilities like this. Okay. So, and at last, what if this one is 23rd of the month? Okay. Then we need another 0. Okay. It's like 0 and a 2 right over here. Okay. So it will be only 1 more. Okay. This would be the last one. Okay. 23rd. So we're going to have a 2 plus a 3 and a plus a 4. So we'll make a total of 9. So at least when you get 9, you feel free. Okay, I found 9 ones, like 9 dates. So I'm right. Okay, so that's problem 9. Okay, let's do problem 10. This is the last problem for this video. Okay, so Maureen is keeping track of the mean of her quiz scores on this semester. Okay, the mean will be like the average. So for this one, I'm just going to assume this is M. Okay, so this is M. So if Maureen scores an 11 on the next quiz, her mean will increase by 1. If she scores an 11 on each of the next 3 quizzes, like her mean will increase by 2. What is the mean of her quiz scores currently? Okay, so if you don't understand, you read this question, you still don't know what to do. So you just have to come up with some numbers. Like, what if the numbers are like 1, 2, 3, 4, and 5? Okay. What is the average of these numbers? What do we do when we find the average? You add all of them, 1 plus 3 plus 3, and then you divide it by 5. Okay. So when you add all of these numbers together, it will be 15. Okay. When you add all of this number. So you divide it by the number. We have 5 numbers. So the average, the mean will be 3. Okay. So now let's go. How many numbers do we have? N numbers, 5. Okay. So the sum of these, 1 plus 2 plus 3 plus 4 plus 5, is always equal to the mean, 3, multiplied by the number n. Okay. So m times n is always the sum of this number. Okay, now let's go. Imagine we add an 11 to this one. So we already have this number, mn, and then we add 11 to them. Okay, so the sum will increase. Okay, but because we added one number, we had 5 numbers, n, it will be n plus 1. Okay, we just add 11, one more number. And when we do so, m will also increase by 1. Okay, that's one equation. So here it says, what if we add like 3 11s? 1 11 plus 2 11 plus 3 11. Remember, the sum of these, 1 plus 2 plus 3, was m times n. Okay, plus 3 11s is 33. We had n numbers, in this case, for example, 5. It will be n plus 3. Okay, so, and then the mean will increase by 2. Okay, so there you go. You have 2 equations and you just need to solve them. And when you do so, you'll find m. Okay, so let's just start by the easiest one. Okay, I just cross multiply. So it will be mn plus 11 will be equal to mn plus m plus n plus 1. Okay, so mn, we subtract mn from both equations. So what we're going to have is m plus n is equal to 10. Okay, that's the first one. So I'm going to clean this because we have the result. So we just need to cross multiply this one. So we're going to have mn, so get capital, mn plus 33 is equal to m times n, again mn. We're going to have 2n plus, 3m plus 6. Okay, so again, mn's will be canceled. So what we're going to have is 3m plus 2n is equal to 27. Okay, so how do you deal with this? We have 2n over here. So I will multiply each term by a 2. And then 10 will be 20 like this. Okay, so, and then I'm going to subtract the 2 equations. Okay, this one, if it's equation 1, 1, this is equation 2. I'm going to go like equation 1 minus equation 2. Okay, so when we just write it this way, it will be 3m plus 2n minus 2m minus 2n is equal to 7. Okay, so n's will cancel. We're going to have 3m minus 2m is m. So as you see, the mean will be 7. Okay, so this is the end of this video. Remember, if you need coaching, you could book some lessons with me. You have the contact information. I will make more videos. So if you don't want to, if you want to see other videos, make sure that you subscribe to the channel as well. Okay, let's just start dealing with problem 11. A square of area 2 is inscribed in a square of area 3, creating 4 congruent triangles. Just for our non-native test takers, congruent means similar, they're the same. And by these 4, it means like these 4 triangles that you see over here. It's just saying that all of them are the same and similar. Okay, as shown below. What is the ratio of the shorter leg, which is going to be this part, to the corner leg of this one shaded area? So we just want to find these two, okay, the ratio of these two, okay? So so let's focus on this red side. What is this red side? If I told you we have a square and the area of the square is 4, you would just go, okay, square root of 4 is 2. So you would just say, okay, the side is 2 and the side is 2. Okay, so the same principle. The big area is 3. So the side of that will be square root of 3. And the blue one will be a square root of 2. Okay. So in this case, what do? We just have to write an equation. Okay. So because it said that all of these are congruent, that means this part, this part, this part, and this part are all equal. So let's just give them a new name. So I'm going to assume this part will be A. Okay. So the red one, okay, the red side over here from here to here will be a square root of 3 minus A. Okay, so I'm going to write it here. Okay, all of it is square root of 3. This will be a square root of minus 3. And you would see that this short side is again, okay, this one, the square root of 2. So we just have to write the Pythagorean formula for this right triangle, okay? So it's going to be a square root of 3 minus A is squared plus A is squared, this one, will be the square root of 2 squared. Okay, so all we really need to do is just to expand this one. Okay, now let's expand the first expression. It will be 3 plus A squared minus 2 square root of 3A. Okay, plus this one. A squared and the square root of 2 squared will be 2. Okay, so let me just write it. So we just have to deal with this quadratic equation. It's going to be like 2A squared minus 2 square root of 3A. Okay, plus 1 is equal to 0. Okay, let's continue like this. So I'm just going to use the quadratic formula. Okay, so it's going to be minus this one. It's going to be positive 2 square root of 3 plus minus square root of this one is squared will be 12 minus 8. Okay, divided by 2 times of this, which is going to be 4. Okay, so this, the value of this is going to be 4. Square root of 4 is going to be 2. So when I simplify it, so the value of A will be, okay, square root of 3 plus minus, okay, 1 divided by 2. Okay, so now the question we need to ask ourselves, which is possible for this one to be true? We just want the value of A. Will it be the positive one or the negative one? Okay, now because we selected A as the smaller part, so I'm going to continue with the negative one. Okay, you could also continue with the positive one, still will be correct. So if this is the value of A, now we want the value of this part. Okay, it would be the larger side of the triangle, the larger leg. So all I have to do is just write this one. All of this, the red one, was the square root of 3 minus the value of this. Okay. So this value would be 2 square root of 3 minus the square root of 3 plus 1 divided by 2. Okay. So you will see that the larger leg will be a square root of 3 plus 1 over 2. Okay. So we want the larger one, which is this one. Okay, this would be the larger leg. Okay, this would be the smaller one. So we just need to find the ratio of these. Let me do some cleaning. Now the question is looking for the ratio of the smaller leg over the larger leg. Okay, so as you see that the square roots of these two will cancel. So what we're going to have is the square root of 3 minus 1 square root of 3 plus 1. Okay, and this is not either of the options. So what we really have to do here is multiply both of them by square root of 3 minus 1, square root of 3 minus 1. Okay, so you know that this is actually just 1. We're not changing the fraction. So what happens here? This one will be the square root of 3 squared, okay, minus 1 squared. Okay, so it will be 3 minus 1, which will be 2. Okay, so this one will be a square root of 3 squared minus 2 square root of 3. Okay, plus 1. So what we're really going to have is going to be like 4 minus 2 square root of 3 divided by 2. And finally, you would see 2 minus the square root of 3. So this would be the final one. You don't have to go, you don't have to write whatever I wrote here. So the reason I just expanded so much and explained so much, so that if you are confused at any part, maybe this will help you. Okay, let's deal with problem 12. I don't think it's really that difficult. How many 3-digit positive integers n satisfy the following properties? The number n is divisible by 7, okay? And the number 4, by reversing the digits of n, is divisible by 5, okay? So let's just write a number. So for example, I'm just going to write a 3-digit random number, okay? So if I reverse this one, it becomes 411. Is 411 divisible by 5? No. Okay. So this digit is becoming this digit. Okay. If I want this one to be divisible by 5, this one has to be either 0 or either 5. Okay. So this one can either be 0 or 5. But if it's 0, it's going to be a 2-digit number. So we're not going to accept this. So this should be 5. So what does that mean? That means all our numbers should start with 500. Okay. So we have to find the numbers that start with 5. Okay. That are between these two, 599, that are divisible by 7. Okay. So we just, this is a simple counting question. What is the first numbers like that? So we know that 490, right? 49 and 7 is squared, is divisible by 7. So 497 is, okay, plus another 7 will be 504. So the first number that is divisible by 7 is 504. The next one will be 511. Okay, the next one will be 518. Okay, so you could write down all the numbers, or you could do something like this. Okay, so the first number is 504, and we just want to multiply everything by 7. Okay, so, and this one still has to be less than 600. Okay, so if you try that, K13 will work. Okay, so it's going to be like 504 plus 13 times 7. okay, which would be 91,595. Okay, so, but we have to be really, really careful here. Will the answer be 13 or not? Okay, so remember, the first one, if you put k here, okay, if k is 0, it would be our first number. Okay, so you really are counting these numbers from 0, 1, 2, 3, and all the way to 13. Okay, so don't forget this 0. Okay, because if you forget that one, you're going to select 13, which is going to be wrong. So you have to include this one. So it will be like 14 numbers. Problem 13, A and C are standing 48 feet apart in a field. Okay, so I'm going to draw it like this. Instead of Abdul, I'm going to write just A, and this will be our C instead of Chiang. So B is standing in the same field as far from A, okay, as possible, so that the angle formed by his lines of sight to Abdul and Chiang measures 60 degrees. So we have this person B, okay, and the eyesight will be, so for example, if the B looks at C this way and B looks at A this way, it will create an angle. Now here it says that this angle should be, okay, 60 degrees, okay. So we just have to realize where actually B is supposed to be, okay, because it says we want it to be as far away as A. So you see, now if we put B this way, right, the angle would be really sharp, right? This would not be a 60-degree angle, okay? So as you come closer to A, this angle starts to increase and gets larger. And when this is 90 degrees, okay, so this would be the angle that we're looking for. So now if we suppose B is here, okay, because here it says 60 degrees, so here we'll have like 30 degrees, okay? So we know that the distance between A and C is 48 apart, okay? Now here, because AB is the hypotenuse, I'm going to call it hypotenuse, okay? So the line opposite of this 30-degree angle, we know is going to be half of H, okay? So let's just find it. So I'm going to just write a very simple equation. Let me just clean this one first. Okay, so we're going to get H over 2 squared plus 48 squared is equal to H squared, okay? So I will just expand this. It will be 48 squared will be equal to 3 over 4h squared. Okay, so to find, the question was only, okay, h squared, so the answer will be equal to 48 times 48 times 4 and divided by 3. So once you do that, the answer will be 3,072. Okay, not a difficult one, right? Okay, problem 14. I think this one is all about understanding it. If we understand the question, I think it's very easy to get it right. A number is chosen at random from among the first 100 positive integers. Okay, it's going to be like 1 to 100. We're going to select one random number. And a positive integer divisor of that number is then chosen at random. Okay, like for example, imagine I pick 87. Okay. So what are divisors of 87, right? It could be 1. Okay. It could be 3, right? So what could be 87, right? It's just we select one of them again, one of the divisors. What is the probability that the chosen divisor is divisible by 11? So for example, in this case, what is the chance that the number that we chose here is 11? So for example, if we choose 87, 11 is not a divisor of this. So there's no chance. Okay. So we have 100 numbers, right? So let me just go right. If the first number that we choose is 1, right? Is 11 divisor of this? No. So what is the chance of that happening? 0. Okay, 0. What if we choose 2? 2. Is 11 a divisor of this? No. Again, 0. So you would see that we just have to write 0 plus 0 plus 0. And the first number that we have to deal with is 11. Now, if the first number we choose is 11, 11 has only 2 divisors, okay? Either 1 or either 11. What is the probability that the chosen divisor is divisible by 11? If you choose 1, no. If you choose 11, yes. So it's going to be 1 over 2. And then it will just for 12, 0, for 13, 0, for 14, 0, until we get to 22. Okay. So what are the divisors of 22? It's going to be maybe 1, maybe 2, maybe 11, maybe 22. How many divisors do we have? 4. How many of them are divisible by 11? 2. 2 over 4 is again the same as 1 over 2. So let's do that for 33. It's going to be exactly the same thing because it's going to have 1, 3, 11, and 33. So let's just check 44 because 44 will have more factors. It could be like either 1, 2, okay, 4, 11, 22, and 44. Again, it will be 3 over 6. So it's going to continue, right? For 33, 44, 55, 66. And the first one was 11. The last one is 99. So how many of 1 over 2s do we have like this? 9, okay? So it will be 9 times 1 over 2 divided by 100. So this would be equal to 9 over 200, right? Not a difficult one, was it? Okay, this problem has the potential to waste a lot of your time and kill the test for you. So let's just read and understand it first. An even number of circles are nested, starting with radius of 1. So this one, radius of 1. What is the area of this? Pi 1 squared. The area of this will be pi. Okay. And increasing by 1 each time. So for example, this one, the radius of the one, this here, from here, this will be 2. So the area of this one will be 4 pi. Okay. So let's just read it here. All sharing a common point. The region between every other circle is shaded, starting with the region inside the circle of radius 2, but outside the circle of radius 1. Okay, so for example, if we only have 2 circles, okay, so the big circle would be like 4 pi. The small one will be minus 1 pi. Okay, so if we take out pi, it's going to be pi 4 minus 1, which is going to be like 3. Okay, so let's continue this. And an example showing 8 circles is displayed below. What is the least number of circles needed to make a total of shaded area? Okay, so let's just deal with the next one. Imagine we only have 4 instead of 2. So it would be this big circle. Okay, the radius of this will be, this is 2 here, this will be 4. So this one will be 16 pi. The one that is inside it, okay, so from here it was 1, 2, 3. It would be here. It would be 3 here. So minus 9 pi. Okay, so again, if we take out pi, it will be 16 minus 9. Okay. Okay. Now, as these circles continue, these numbers will also continue. But one thing, you see that now the final result has pi. These have pi's. So this pi will be canceled by all the pi's that we're going to add. So I'm not going to just write them. I'm going to ignore writing them. Okay. So the first one, okay, will be, I'm going to write it like this, 2 squared minus 1 squared. Okay, for the first 2 circles. For the next 2, as we had it here, it will be 4 squared minus 3 squared. And let's continue. It will be 6 squared minus 5 squared. And this will continue. And the last one, okay, which is going to be an even number, is going to be n squared minus n minus 1 squared. This will be odd. And this has to be larger than 2023. Okay, this is the part that could waste a lot of your time. Okay. So let me just write it this way. I'm going to clean this part. Okay. So this part, oh, look, we could write it as 2 plus 1, okay, times 2 minus 1, which is 1, right? So why bother? I'm going to write it like this one. So these two are equal to 1 plus 2. Now these two are again equal to 4 plus 3 times 4 minus 3. So 4 minus 3 is 1. Why bother writing it? So you could say something beautiful, right? The first two are 1 plus 2. These are equal to 3 plus 4. So let me just write them like this. This will be 1 plus 2. So this will be plus 3 plus 4. So the difference of these two, okay, will be 11, which is equal to 5 plus 6. Okay, and this will continue all the way, okay? So it will be n minus 1 plus n with the same reasoning. Okay, this has to be larger than, okay, 2023, okay? Now everything looks a lot simpler, okay? So all we really have to do is just write it this way. Okay, we know that the last one, 1 plus n, okay, divided by, okay, n over 2 is supposed to be larger than 2023, okay? So we know that 1 plus n times n is supposed to be larger than 4046, okay? So which number would do that? We want the smallest number that will do this. So now at this point, if we try 60 instead of n, it will be 60 times 61, okay, which will be 3660, which is not going to be large enough. So definitely the answer will be E64 times 65, okay? Okay, problem 16. In a table tennis tournament, every participant played every other participant exactly once. Although there were twice as many right-handed players as left-handed players, we're not going to use this piece of information. We don't need to. The number of games won by the left-handed player. So I'm going to write it like this. The number of games that were won by the left-handed players okay, was 40% more than the number of games won by the right-handed players, okay? So there were no ties and no person who could use both of their hands. What is the total of number of games played? Okay, so they're playing, right? Either a person with left-handed wins or either a player with right hand wins. Even if like two right-handed players play, okay, a right-handed player will win. So that would be like all the games, okay? So it's gonna be like all the games, okay? Let me write it. So now here it says that this one, the left-handed, is 40% more. So my question to you is, can this number be any integer? So for example, can this one be 11? Okay, if we add 40% to 11, will that be an integer? The answer is no, it will not be an integer. Okay, so that would limit the number of options that we have. Okay, so let's apply that. So here it says 40%. We know that if you add 40% to 100%, it's going to be like this, 140 over 100. Divide both of them by 100 is going to be 1.4. So I'm going to write it this way. Okay, so 1.4 of GR, okay, instead of the games won by the left-handed people, okay, plus G, the games won by the right-handed people, will be all the games. It will be one of the numbers here, okay? So if I factorize, okay, GR, it will be 2.4. My pen is not writing. So it will be 2.4 of GR, which is going to be the games won by the right-handed people. It has to be an integer. When you multiply it, this again has to be an integer. That means which of these number we divided by 2.4 still would be an integer. Okay, so when you do this, this will be out, this will be out, and this will be out. These are the only two numbers that are possible for the total number of games. Okay, so now here, how many participants are allowed to be there? Imagine you only have two participants, A and B. How many games? One game. Okay, if we have three participants, A would play with A play with C, 2, and B and C play together. So it would be 1 plus 2. If I add another player here, A would play with all the three. Okay, so it will be 3 plus, okay. And then B will play with these two, plus 2, okay. And then C and D play. So you would now pay attention to one thing. When we have 4 participants, it's going to be 1 plus 2 plus 3, not plus 4. Okay, this 4 is missing. Okay, so if we have n players, it's going to be 1 plus 2 plus 3 all the way plus n minus 1. Okay, so what would be the general formula for this? Okay, it will be n multiplied by n minus 1 divided by 2. Okay, so now which one will follow this formula? Okay, so for example, if we have 9 for n, if we have 9 participants, it will be 9 times 8 divided by 2, which is going to be 36. This one is okay. Okay, if we have 10, okay, it will be 45, but this already out. So if we have 11, look, if we have 10 players, it will be 45. If you have 11 players, there will be 55. So there is no way there could be 48 games played, right? So that would just make 48 out. So the only option left would be option B over here. Problem 17 is incredibly easy.
If you can't do this problem, that means you haven't mastered a few things yet. But once you do, which I'm going to just show you how, then you'll have no problem with this type of questions anymore. See, let me just test you before I actually get you my point. If this one is 21, okay, and this one is 28, what is the sign? Okay, I see a lot of students will go, okay, so let me calculate. They would really square this, and they would really square this, and then they want to square root, and they will make a mistake. So they would end up with something weird, but we're not going to do it like that. They forget that this 21 and this 28 are both divisible by something. See, let me give you my point here. Now, if I ask any of the students who couldn't know this one, if I say this is 3, this is 4, they say, oh, 5. And I say, if you know this one, then you must know this one. Because these two triangles are similar. This has been multiplied by 7. This has been multiplied by 7, so must the last one. So the answer to the problem is 5 times 7. So the original question was 35. Okay, so that's how you should do this problem here. You don't want to calculate all of that. If you want to do this question will take 20 minutes, 15 minutes. You don't want to do that. It's very quick. So all you really need to know is these few that I'm going to write down here. And you probably know most of them. So you tell me 3 squared plus 4 squared is equal to 5 squared. Okay, of course. And the next one will be, let's see, 5 squared plus 12 squared is equal to 13 squared. 8 squared plus, okay, let's see here, 15 squared is equal to 17 squared. Okay, so basically you must know this one. Like these three are, most of the questions are from this tree. There is one more. You may want to learn it. 7 squared plus 24 squared is equal to 25 squared. Okay, so this is like all you really need to know before you're able to do this question very quickly. Now I could pick any of these problems and just multiply them by weird numbers. So for example, let's take this one and multiply it by an evil number. So for example, so the most evil number I think is 7. So in a question they will write this is 35, this side is 35. I multiply this one by 5, this is 60. No, I multiply by 7, this is 84. And God, then I will ask you what is this side, right? It's just the multiple of these like numbers over here, these triplets. Okay, with this, okay, the question is extremely easy. Okay, let me just draw a diagram and then we'll continue the question. Now let's actually see how easy this problem really is. Let ABCD be a rectangle with AB being 30. So this side is 30. BC from here to here is 28. Point P and Q lie on BC. Okay, and CD here, respectively, so that all sides of ABP, PCQ, and all these three triangles that I'm going to draw here, ABP, so from here to here, ABP, and then PCQ is going to be this one, and then QDA. They all should have integer lengths. What is the perimeter of the triangle inside? So we have two of the sides. We could either start with this 28 or this 30 because I know that this is actually 30. Like this side we're not sure, this side we're not sure, but this one we're sure. So let's start from 30. So which of these could this one be? So for example, if it's following 3, 4, 5 triplet, that means this has been multiplied by 10. So this side should be multiplied by 10. So it should be 40. Like from here to here should be 40. So which is impossible. So it's not this one. Then Could it be this 5, 12, 13? So then this has been multiplied by 6. No, it's going to be way too large. So I think it's kind of obvious that it has to be this one because of the 15. That means this has been multiplied by 2. Okay, so this is the hypotenuse. This one is the 17 one, and this one is the short one. So everything has been multiplied by 2. So from here to here, let me highlight it by the orange that we have, it's going to be orange. So from here to here is going to be 2 times of 8, which is 16. Okay. And this one, I'm going to highlight it again. From here to here is going to be 17 times 2. So this is easily 34. Okay. So BC is 28. 28 minus 16 is actually going to be a 12. I'm going to highlight that one with a different color. Let's do that. So if this is 12, now 12 could be which of these? I think it's obvious it's going to be this 3, 4, 5, right? It's not going to be any, because 12 is not going to be divisible by any of them, only this. But this side could be the 3 or could be the 4 because 12 is divisible by both of them. So what I mean is, if this is 12, this could be the side that is actually 3. Then this could be the side that is actually 16. And then this will be, everything has been multiplied by 4. So this would be 5 times 4. This will be 20. Okay, maybe it's like this. Or maybe this side is actually the 4. Okay, so this would be the 3, 1. Remember, the Q was random. I just drew it here. Maybe this is the 4, 1. This is the 3. This is the 5. This is actually the 12 here. So this will be this would be the 12. This would be the 9. This would be the 15. So we have these two possibilities. So now we have to choose one of them and see what happens. So I would go, if this one was 12, let's see, this is 3. So this is 3 times 4. This is 4 times 4, 16. This is 5 times 4, 20. If this is 16, this will be actually 30 minus 16, 14. And good, looking good. Now this would be the same as BC, which is 28. Both of these are divisible by 14 and 28 by 14. So this triangle would be similar to 14 divided by 14, 1, 28 divided by 14, 2. So this will be root 5. It's not an integer. So our assumption was wrong. We have to go back. So that means this side that was 12, okay, this is the side that is actually 4. So that means this 3, 4, 5, it's this side has been multiplied by 3. This side should be multiplied by 3, which is going to be 9. This side should be multiplied by 3. Okay. So, but my diagram looks different than this. So this is 12. Then from here to here is actually 9. It was supposed to be a smaller. And from here to here will actually be, okay, 5 times 3, 15. Okay. Now this one is 9. 30 minus 9. That means from here to here is a 21. Okay. And this was a 28. So 21, 28. So both of these are divisible by 7. So 21 divided by 7 is 3. 28 divided by 7 is 4. This one is the 5. 5 times 7 is 35. This is the example I asked you early. So you see now, 2 of these triangles were just this 3, 4, 5. Once they multiply everything by 3, they got the purple one. Then they multiplied everything by 7, they got this red one. And now they chose this one again, and they multiplied it by 2, and then they made that question. So, okay, if you know all of this, if you practice it, it's very easy. So all we have to do is add these numbers of all these hypotenuse. This one plus this one is 50 plus 34, 84. That makes the answer to the problem is option A. Probably this question is difficult for you, and the main reason is that we haven't done a lot of similar problems to this one before, and that's why it's very difficult for us. But even if this is the case for you, I think with good problem solving skills, you could still answer the question. Let me just show you how. A rhombic dodecahedron is a solid with 12 congruent rhombus faces. At every vertex, 3 or 4 edges meet. Depending on the vertex, how many vertices have exactly 3 edges meet? Very weird. But I'm going to show you, first of all, if you know this name or not, it doesn't really matter because we have the definition. It has 12 congruent, like equal, rhombus faces. Good, we know all rhombus. That's a rhombus, of course. For those who may not know, this is a vertex. All the points are vertex. And if you have more than one, then we don't call it vertexes. We call them vertices. Okay, and edges are going to be the side length. Okay, in case we just don't know these words. And let me show you how we're going to do a problem like this. Okay, if you want to start with this problem right away with no experience, that's very difficult. But let me show you how you could do it. We just go with some, okay, shapes that you already know, right? We all know a cube. We all know we have seen a tetrahedron. Let's go analyze these simple ones and get experience and then go back and do this problem. So this tetrahedron is made of how many faces? There is one base and 3 more surrounding it. So it has 4 faces. The number of faces is 4. Okay, how many edges does it have? There is a triangle below here. That's going to be 3. And 1, 2, 3 more. So it has 6 edges. You could count for yourself. Okay. So, and then let me just write the number of vertices first. Like how many points does it have? 1, 2, 3, 4. So the number of vertices is also 4. And the number of edges we just counted is 6. Okay, good. Now let's go do this for a cube. So it's going to be easier for a cube. It's going to have 6 faces. Okay. How many vertices or points does it have? 4 points below, 4 points up. It's going to have the number of vertices is 8. Okay. The number of edges is going to be this face 4, the one in the back 4. Okay. And there will be 4 connecting, so it will be like 12. Okay. So now let's look. If you have seen this formula before, or we have heard of it, or look at it once, it's like this. All the time, these two, 4 plus 4, is 2 more than the other ones, right? So for example, 4 plus 4 minus 2 is this. 6 plus 8 minus 2 is 12. That is what we call the Euler's formula, right? So that's going to be like this formula. F plus V, if it's subtracted by 2, that will give us the number of edges. Okay. So you maybe if you could just not memorize this, you just know that there is going to be like 3 of them and minus 2 is going to be the other one. You would just, in any case, you would just draw yourself a cube and figure out the formula. This is what I do. I don't like memorizing formulas. Okay, so this is very good. Now, the next thing we need to do is we have to ask ourselves, like this is made of a triangle, right? And let's see what a triangle has. Obviously, it has like one face, or it's just one triangle, not one face. So, and then it has 3 vertices, okay, and it has 3 edges, obviously. This is made of 4 triangles. Now, okay, that means this was made of 4 of this, 12 vertices, okay, and 12 edges. But now look, let's just do a comparison. This is where we could teach ourselves how to do a problem like this. So 4 faces, okay? And the number of edges, well, has been divided by 2. But maybe before we do that, let's just do this for the square ones as well, because here now we have 6 squares, and one square has, okay, obviously one face, okay, 4 vertices and 4 edges. So it's going to make a total of, so 6 faces here, 24 vertices, and 24 edges. Now this is where the learning will happen. In all of these cases, right, you could see that the number of edges has been divided by 2. Okay, and there is a reason for it, right? Because, for example, here, let's see, for example, this edge. This edge is common between 2 faces, this one and the other one, right? So that's why we see it as one edge, but it was really 2 edges. One face had this edge. This is when we combine it, the 2 become 1. That's what's happening here. Okay, so and then look here, the number of vertices here. This was 12. Okay, this one has been divided by 3. Okay, here this one 24 become 8. This one has been divided by 3. And basically, why is it? The same reason, because now this point was this here was common between this, and between this. So that's why we're dividing it by 3. So this point was made of 3 different points. We join them together. So they're going to be divided by 3. And that's why we're going to have this 8 here. Okay. So this is what we do to teach ourselves like how to do a problem like this. Even we just made our own Euler's formula, right? So now let's go and deal with the problem in the question. So let's see, it's so much easier now. We have the Euler's formula. So we have like a rhombus. This is a rhombus, and we have 12 of it. So that means we have 12 faces, okay? We're going to have 48 vertices, and we're going to have 48 edges, okay? So now let's see here. We're gonna use this one, but we're gonna combine them together, right? So let's see what happens when we combine them together. When we join them together, of course, this 12 face, like the other examples we said, is still after joining it going to be 12 faces here. Make it purple. And as I told you before, like all the edges were divided by 2, because when 2 faces just join, 2 edges become 1. So that means we can have 12 faces, and we know that the number of edges will definitely be 24. So now we just have to plug that in this formula. This is going to be a 12. This is going to be a 24. This is going to be 10. So there you go. We made the number of vertices. The number of vertices is actually 14. Okay. So now this 48 vertices, okay, became 14. Right? Previously, in the examples we had, they were always being divided by 3, right? So we had 12, they were divided. But now the question says, this 48 vertices, some of them are divided by 3, or some of them are divided by 4. When the division happens, they're going to be 14, right? If all of them are 3, it's going to be 16, not 14. If all of them are divided by 4, okay, they're going to be 12. Okay, so it's going to be some of them, right? Okay, now we need one more step to finish this question. So these 12 rhombus, when they are separated, they have 48 vertices, right? But when we join them, these vertices go together, they become one. So like in all those examples that we analyzed, these three lines, they 3 vertices come together. So the 3 vertices become one, right? So, but now the question says, it's not going to be like this. This shape is weird. Some of them are going to be divided by 3. Some of them are going to be divided by 4. So there are 2 ways to go. You could do trial and error, cut the numbers, maybe like, for example, 36 plus 12. Divide this one by 3. Divide this one by 4. That's a 12. This is a 3. It's going to be 15. It's still too much. So you have to cut them 24 by 24. That will be the answer. So it would be like, so 24 divided by 3 plus 24 divided by 4. Okay, this is going to be an 8. This is going to be a 6. 6 plus 8 is 14. So this is the right answer. But now how many vertices have exactly 3 edges meet? Okay, 8 vertices. Or you could write an equation. I think equation is a lot easier. So some of these vertices, okay, they're going to be multiplied by 3. Okay, they're going to like share 3. Some of them are going to share 4. Okay, and this is going to be 42, 48, sorry. And we know V1 plus V2 is going to be 14. Okay, so you could solve these 2 equations, and the answer would be this one would be the answer to the problem, which would be the value of the.
Okay, let's do problem 19. This problem is actually not very difficult, but probably you can't do this question. Even if you read the solution to the problem, still you wouldn't understand what's going on. But that doesn't mean the question is difficult. That means probably you don't know some of the fundamentals. If you know everything, then this question would not be difficult at all. Okay, so let's go and learn all the fundamentals related to this problem, and then we're going to do it together. You see that it's not going to be that difficult. So the first thing that I want us to practice before doing the problem is learning about rotation, okay? And some of you might be confusing reflection and rotation, so I have to teach you both. Imagine this is this line, we have it, and this is this point here. I want you to reflect, not rotate. Reflect. Okay, we're going to learn about reflection. We're going to reflect this point with respect to this line. Okay, I have to go this amount on perpendicular 90 degrees, and I have to continue the same amount. That's it. So reflection of this point is here. Reflection of this point is here. Okay, with respect to this, okay, line over here. Now I'm going to ask you this. What is the reflection of this point? It's going to be right over here because it's going to be the same amount. What is the reflection of this point here? We'll go 90 degrees perpendicular to the line, continue the same amount, right? It's going to be right over here. Okay, what is the reflection of this point with respect to the line? It's going to be itself again, right? So that's reflection. So now sometimes they might ask us to reflect, okay? Not just with the line. So I want you to reflect this point. Imagine this is y and x degrees, right? So let's reflect it, okay, with respect to the origin, reflection with respect to this point. You would go exactly to this point that you want to reflect, and then you would continue the same amount. Okay, that's again reflection. What is reflection of this point? Right over there, here. Okay, so now that we have learned about, okay, let's also reflect a line. Okay, I didn't teach you that. So now how would you reflect this line? You learned how to do a point. Now let's just see here. If it's this one, I'm asking you to reflect the line. Let's call this one A, this one B, reflected with respect to the origin. Okay, a line is made of infinite points, right? So when you are reflecting a line like this, you're still reflecting points, not the line itself, right? You could pick any of these points here, and then you would continue the same, and it would be here. So if this is C, this is C again. And to reflect, to find a line, we only need 2 points of it, right? So that means let's just find A first, the same amount, and then I'll continue the same amount. That's going to be my A prime. And for the B part, if I go like this, it's going to go right below here. So it's going to be probably outside the page. So this will be my A prime and B prime. Let's just, this is a reflection of A, this is a reflection of B prime. But remember, the length don't change. This one is equal to this one. Okay, that was all about reflection, right? But we're gonna do a rotation. I didn't teach you about rotation. The reason I told you this because you might confuse them. So it's good to learn them right now, okay? So let's do this. Now we want to learn about rotation. Okay, not reflection, rotation. Okay, imagine we want to rotate it again against the center of X and Y axis. The reason I do it like this, probably you learn better. So this is X axis, this is Y axis. Okay, we want to rotate it. Rotate it by what degree? So we want to rotate it against the origin. If I ask you to rotate it 30 degrees, this line, the point will be go here. If this is A, this is A prime, and the angle over here is, for example, 30 degrees. That's how we rotate. So to make it even better for you to understand, see, rotation happens in a circle. So let me go, for example, here, I'm gonna choose a color here, for example, red. Okay. So let me grab this. Rotation happens. Okay, you put this, okay, the origin becomes the center of rotation. We're just gonna rotate it here. And now it's gonna be like this. We're rotating this point A, okay, with respect to the origin. And if we go, for example, we say I want rotation of 30 degrees. This point will go here, given that this is 30 degrees, right? If you say I want to rotate it 90 degrees, this point will go here. How do I know it go here? Because I think this is like 90 degrees, this one. That's how it goes. If I ask you, rotated 180 degrees, something interesting will happen. It goes exactly here because this now is 180 degrees. And you would see now this rotation 180 degrees is equal to the reflection that we discussed like 5 minutes ago in the video. So, right, this is how you would rotate. And the key point when rotation happens, let's go, for example, this 30 degrees rotation, okay, is going to be the distance is always equal, right? So that means this distance is the radius, of course, is always equal. And now to practice even better, So I'm going to now, well, let's rotate a line this time, right? It's not going to be difficult. So let's see, I'm going to rotate, let's see this one. Okay. This is A, this is B. Okay. And now A rotated with how many degrees? It could be anything. Well, usually I ask my students to come up with an idea. Let's go still with that. Let's go 90 degrees. Okay. So now A, 90 degrees, we already discussed. A would go here. From here, 90 degrees will be here. Okay, this would be your A prime. Okay, you would see now this is the radius. For B, okay, B will go a smaller circle, right? Because it's closer to the origin, right? So it would go inside this circle. I'm going to draw it and then I'm going to clean it. This is just for you to see. So B will go, because it's closer to the origin, the rotation that this one does, it will be smaller, right? So from here, I have to go 90 degree again. I think it will be something like here. Okay, this will be your B prime. But again, you have to know that this distance is the same as this distance because rotation happens in circle and it's a radius. Radius is always the same, okay? So now I think you would understand the solution to problems. So this is, I'm going to clean it as I promised. So this B will go somewhere here. We just drew it here. This is going to be our, because this is equal to this distance, this is your B prime. And now look, if I connect them together, that's again the same thing, right? AB and A prime B prime is a line. When you rotate it, it doesn't become shorter or longer. Okay, so basically this is what happens. And this is essential for doing this problem. And now I think you understand the rotation. Even if you try to do it alone on your own, probably most likely you will be able to answer the question now. Okay, now let's go and deal with the actual problem. The line segment formed by A and B is rotated to the line segment formed by A prime and B prime about the point P. Okay, the coordinates are R and S. We want R minus S and blah, blah. Okay, so basically, now we know A has become A prime. So where could this point, okay, that we rotate everything by would be? So let's go here. I'm going to just put a random point. Can P be here? So for example, that means we want to rotate. Is it possible? So we just learned that this is going to be AP and it only rotates in circles, right? So for example, if I go this much, A could be, when rotated, could be anywhere here. You would see that if we want to go with this degree, it's going to be here. There is no way P is here because when we rotate it against P, A prime could be any point here. But this one is too far. These two are too near. There's no way that will happen, right? So P cannot be here. So let's go and just choose another point here to see it clearly. This is what you should do on your own when you're trying to deal with a problem for the first time. Okay, you have to teach yourself. This is what I'm doing. So now let's go here. Can P, for example, be closer to here? So you see, if this is the point here, you want to rotate A. Okay, A prime could be only here. There's no way. Now, could P be exactly between the 2 points here? The answer is yes. If the point is here, and if I rotate it by 180 degrees, it goes back exactly here. But is it the only P? Is it the only point here? No. See, I could also go, as long as the distance is equal, then it's fine. So for example, if P is here, I'm trying to put here so that this distance is equal to this distance, then the answer will be possible. So for example, if I go away now, let's go. How many degrees is it? Now I'm rotating it here. So how many degrees is this one? Because I went away, now instead of 180, I rotated 100 degrees or something, right? If I go further away, let's see what happens here. I could go put the point P really away, but again, the same distance from A and A prime. Now the rotation will happen only at, what degree is that? 20, 25 degrees. Okay, so the more away we go, the rotation we need to do will be shorter. Okay, that's basically it. But now with A and A prime, we have infinite answers. And all of them will be, all the values of P will be equal distance. So if this is here, this is going to be the midpoint. What is this midpoint? We just have to go average. 3 plus 1 divided by 2 is 2. So the coordinate is 2. And you could see here is on 2. That means my diagram is good. So, and then 1 plus 2 divided by 2. We could write it 3 over 2, or I could write it 1.5. Yeah, whatever you like. So it's going to be like this one here. So from here, all of these points here that are perpendicular, because there would be the same amount, all the values here, they could be an answer to the question because all of them have the same distance. So that means P could be here, it 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 could be anywhere. So, but the only reason is that we just did it with A and A prime. We just have to do it with B and B prime. So let me just draw B. B is 3 and 3. It would be here. And B prime is 4 and 3. So we want all the points that are the same distance from B and B prime, okay, which would be, again, the midpoint. So this point here is going to be 3 and 3. This one is a 4 and 3. So you would see that this is equal. We only move forward 1 unit from 3 to this 4. So the midpoint will be 3.5 here only. This one is going to be exact. Let me change the color. This one is going to be average of 3 and 4. 3 plus 4 divided by 2. This one is 3.5. And the y didn't change. Average of 3 and 3 is 3, okay? So it's going to be right here. And all the points that are the same distance will be here. There you go. And this will be a unique point, okay? That would actually be the answer to the problem. This is the only one. And that's the unique P that we are looking for. Now, how do you find this point? There are many ways you could do it. So probably the easiest one, let's just go, what is the coordinate of this point? It's going to be like this, perpendicular. It's going to be x equal this line 3.5. When we write the equation of a line like this, what is the value of y? Anything, right? That's why we don't write it here. It could be 4, it could be -2. All of these points are here. That's the equation of this line, okay? So that means we already know the value here, the x value of this point over here, the P that we're looking for. We already know this value here is 3.5. So the value of R here is 3.5. We don't have S, okay, but we could find it, no problem. So it depends like how much you know about equation of lines, but what is the slope of this line first? I'm going to highlight it. What is the slope of this line? You just, if you don't know, you have to learn a little, but the slope here is on y-axis 2 became 1. So we went 1 unit down. That means it's -1. I'm just trying to write the slope. And the x value went from 1 to 3. So it went 2 to the right direction. That's the slope of the blue line, right? And the slope of the purple line is going to be, okay, you would do the reciprocal and you make it negative. So reciprocal for the purple one would be 2 over -1. And you also multiply it by another -1. So they cancel, this becomes 2. So that means the slope of the line we're looking for, the slope of the blue one, like usually we show a slope by m, I don't know why. So I'm going to just use that. The slope of the blue line was -1 over 2. The slope of the purple line is, okay, 2. So this is the slope. Now here, there are again more ways. Some people like to write the equation of this line. We could definitely do that. I wouldn't do it myself. I don't use this, but we could write the equation of the line because we have one of the points and we have the slope of the line. So let's just write it. The equation of the line is going to be y minus this value, 1.5, okay, is equal to the slope, which is 2, x value minus 2, right? So we do this like a lot of different ways. So it's going to be 2x minus 4 plus 1.5 minus 2.5. This is the equation of this line, right? The purple one. And now we have to plug in this value here. It's going to be, I have to plug in 3.5. So let's go. This one becomes a 3.5. I'm plugging in that value. So it's going to be y is equal 7 minus 2.5. So y is equal to 4.5. So I wouldn't do it myself like this. It's too long. Okay. But the reason I show it like this, it would be probably something that you would do. It would be easier to understand. That's why I'm doing it. So that means the y value is here. And we just want r minus s. So it would be 4.5 minus 3.5, which is 1. So the answer is E. Okay. So the way I would personally do it, if you are interested, so the question is over, you could just pass. But the way I would do it, I say, okay, the slope of the purple one is like 2. And then I will write something like this. I would say that, okay, the x value we already know is going to be 3.5. This one minus 2, this one. The y value here, which we don't know, is actually s in the question. So it's going to be s minus 1.5. This is, you could also do it this way, okay? So again, that would be like a 1.5 multiplied by 2, 3, and then s from here will also be 4.5, okay? Which is going to be the same thing. This is easier, right? You just write, because you know the ratio, you do it like that. If you don't know, you could just write the equation intersect, something probably you've learned before, okay? So the answer is E. Well, problem 20 is a probability casework question. Usually these questions are not very difficult, but very tricky. You could overcount or undercount and then make a mistake. So you just have to be very, very careful, okay? So let me read the question first. Each square 3 by 3 grid of the square is colored red, white, blue, and green. And every 2 by 2 square, like this one, maybe this one, maybe this one, and maybe this one, okay, they must have contain only one color. So for example, blue, white, red, green. You can't have 2 colors in this square, basically. And how many different colorings are possible? So once you get to this question, you have to explore different possibilities. It's not like some people read it and then start writing down the answer. Never, right? Everybody will start by exploring the problem. So this is the first one. Now here, the corner here was blue. I'm going to write blue. And then I would ask myself, where can I put the next blue, right? So if I put this one here, this blue here, like the question. So can I put it differently? This example put it here, but we could see that I could also put it here. Like I could have the same color, okay, at every corner. Okay, so that would be one way. And then if I, for example, put R here, I can't put R here anymore. So R will be here. And then the next color, green and green, will be forced here. So then that's completely different. Like we have to count this type completely differently than this one. That's why we do case one, case two, right? So this one is actually not very difficult to do, okay? But here, let's just explore the different cases here. So if I put this blue here, then the other blue could also be here, okay? So if I put this blue here, the other blue could also be here, right? Basically, these are all the cases, okay? So if I put three blues here, and if I put, for example, a green here, then the next green will have to be, but it's actually a red color, green, green, and this one will also have to be color green. And these two will get the next color. So basically, now we could see all the like different colorings. We just have to come up with a way that we just accurately count them. So this is how I would think about them. In one case, we would choose the middle color. For example, it could be white. We saw that the corners could have the same colors. That would be one case. Let's go, for example, count this. In this case, the middle color, we have 4 ways to do. The corners, we have one fewer option, so 3. And then, for example, this one and this one, they have to be the same color, or maybe this one and this one. That would be 2 ways and 1 way. So one such coloring. So for example, red, 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 red. So maybe green and green is here. Maybe green and green is here. So 2 multiplied by 1. I think it's clear. So that would be, okay, this would be one case. But we saw there were different cases too. Like the one here in the question, for example, said this one is blue. Let me also go with the same color. So the other case will be, okay, maybe they are colored like this, or maybe they are colored this way, right? So then we could see we have only these 3 cases, right? When you do these 3 colors, then you will have, then the other ones will be forced. When you have 3 here, let me change the color. So something like this. And the other ones here will be, okay, something like this. That would be the only way. These are like the only total ways that we could do them, right? So basically, for example, if this one is, we choose W here, okay? For the next option here, we have 3 ways, 4 options for this one. For these ones, they have to be the same color 3 ways. For this one, these 3 again 2 ways, and this one multiplied by 1. And you could see that this one is a rotation of this one. This one will be again another 24 ways. So 24 plus 24 plus 24, okay? That would be the answer to the problem. That's only 72, okay? So there will be different ways of doing this problem, okay? It's not just this one only, okay? But the idea is the same. You would explore, and then you would try to put them into groups and count them individually. That would be one way. There are other ways of counting in the solution part you could check out. Okay, now why is this question very simple? All you have to do is just some trial and error. and then you'll find the answer. Let's see how. So remember, we want px to be minimal degree. So we want to keep it short, like small, right? So for example, here it says px has a leading coefficient of 1, okay? 1 is a root of this. So that means p1 minus 1 is equal to 0, okay? So that means p1 is equal to 1. But what does that mean? What is the simplest px that you could write that holds true for this? I would just go, okay, px is equal to x. That's the simplest one, right? Because now if I plug in 1, okay, if I plug in 1, then this becomes p1 is equal to 1. It will be like this, right? That's the simplest one. So we have to go with the simplest one because here I also said minimal degree. So far, px equals x is the answer. So I'm going to keep it now. Okay, now let's go with the other one. So 2 is a root of px minus 2. So I'm going to just write it instead of x. I'm going to write here instead of root. So that means p0 is equal to 0. What does that mean? When I plug in 0, okay, the answer should be 0. So for example, now I plug in 0. This becomes 0. So it is 0, right? P0 is equal to 0. Huh? So far, this is the answer. So now here, let's see. Okay. Now 3 is a root of p3x. So again, we're going to replace this by 3. So it's going to be, again, p3 times 3 is equal to 0. So p9 is equal to 0. What does that mean? Now, when we plug in 0, when we plug in 9, the answer should be 0. But now we see if we plug 9, it will lose 9. So that means this is not enough. We have to add another term to it. The term that we must add is basically x minus 9. And the reason is very simple. Why? So when we plug in 9, this becomes 9 minus 9, which will be 9 minus 0, multiplied by 9. 0 multiplied by 9 is 0. So we write it like this, p9, when we plug in 9, this side, all of it becomes 0, exactly what we want. So that means now we have an additional term here, okay? So this is looking good. So we have another property here. 4 is a root of, okay, 4px. Let's go plug in and let's see what it means. So this 4 has to be plugged in here. So 4p4, p of 4, is supposed to be 0. Divide both sides by a 4. 0 divided by 4 is 0. So we're going to have p4 is equal to 0. Again, what term should I add here that when we plug in 4, the whole thing becomes a 0? We have to have x minus 4 in it. Because now that I plug in 4, it makes the whole thing 0. It's good. Okay, so now we see that it's getting bigger and bigger. So, but again, we want to keep it as minimum as possible. Okay, but now, is px leading coefficient, is it 1 already? Is this correct? Remember, if I multiply this, the biggest term that they create is this one multiplied by this one multiplied by this one. So the biggest term is going to be x cubed. And there will be some other terms here, blah, 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 x squared, blah, 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 x, blah, 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 a number. But this term is 1, so it's good. So which term is not satisfied? Which property is not satisfied so far? This is satisfied. This is satisfied. This is satisfied. This is satisfied. This one is not satisfied. This one. So let's just check. Now, if I plug 1, everything, if I plug 1, this thing. Now we know that if I plug this 1, 1, 1, 1, 1, again, minus this one is supposed to be 0. Is it? Let's just plug in 1. 1 times 1 minus 9 is -8, -3. And this one, minus 1, this is the minus 1 I'm writing, It's supposed to be 0. Is it 0? No. So we need to correct for that. So now, as I said before, this is 1. 1. 1 is not good enough. One way to correct for it is to add a coefficient here. So maybe I put, for example, 1 over 10 is needed, blah, blah, blah. But the question says leading coefficient is 1. So we can't really play with this coefficient here. We can't really change that. So that means we have to have another term here. What is this number? We don't know. So I'm going to put A here. Now, we just have to follow this. When we plug in 1, okay, so P1 minus 1 is equal to 0. Let's go. This is the property. I'm going to write it. We have to just follow this. In other words, P1 is supposed to be 1. So we just have to correct for it. I'm going to go plug in everything here. So P1, I'm going to plug it here. This one is 1. X minus 9 is negative 8 times negative 3. And X, I'm going to plug in 1 minus A is equal to 1. So that's it. So now P1 is supposed to be 1. So that means this side will be 1, right? Which means this one, all of this is supposed to be just 1. Negative 8 times negative 3 times 1 minus 8 is supposed to be 1, right? I'm going to write it here. Negative 8 times negative 3 is positive 24 times 1 minus A is supposed to be 1. So divide both sides by a 24. That's going to be 1 over 24. Okay, so the whole thing is going to be A is equal to 1 minus 1 over 24. So A is going to be 23 over 24. That's it. So now the question is saying that the root that is not an integer can be written as m over n, and m over n are relative prime integers. So that means what I said, we can't really simplify them. Can we simplify them? No. So they are prime relatively. So what does the question want? M plus n, so 23 plus 24 is 47, okay? So the answer to the problem would be just option D. Well, problem 22 is not difficult in a sense that all you have to do is find one right triangle, use Pythagorean theorem, and find the answer. But to be able to do that, you need to understand the question better, right? All this data, this diagram. And let's just do that first. Circles C1 and C2 each have radius 1, and the distance between their centers is 1/2. Circle C3 is the largest circle internally tangent to both C1 and C2. So basically that's like C3. Okay, internally tangent, it means like these parts. These parts are tangent. And this one are tangent. Okay, so, and circle C4 is internally tangent to C1 and C2. So it means like these are touching C1, the big circle, and C4 are touching here. Where they're touching, these are like the tangent points, right? And this is also tangent. So, and circle C4, the small one, is internally tangent to both C1 and C2 and externally tangent to C3, which is going to be like this point here. What is the radius of C4? Okay, so let's just start doing it. So first, I want you to focus on C1 only. Let me make it better, like here. So I'm going to put this one C1 so that all of us will be focusing on the same place. So this is C1, right? What is the radius of this circle? It's 1, right? So from every point here is 1. So if I happen to put it here, okay, so we know that this is 1, right? So, and from here to here, all of it is 1, and this is 1/2. So what is this part now? You tell me. All the radius was 1 minus 1/2. So that's going to be another 1/2. And if I do this, so this is going to be from here to here. So from here to here, everything going to be 1/2. Okay, so from here to here, okay, by symmetry, right? If we do it for the other circle, this is again 1/2. Okay, that's very good. So then let's focus on C3. Can you tell me what is the radius of this circle now? The smaller, this one, not the smallest, but this one over here. Let me make it smaller. So something like this. So what is the radius of this circle? We know that the diameter from this point to this point is 1/2 plus 1/2 plus 1/2, which is 3/2. That's the diameter. And what is 1/2 of this? That's going to be 3/2 divided by 2. That's going to be the radius. So that means from here to here is going to be 3/4. So that's very good. We have that radius here figured out. So most students will do this now, right? So I'm going to draw this right triangle. I'm going to go from this point all the way here. It's going to pass the center of C4 as well. And here, here. Is that a good right triangle? Can I use this to find the answer? Let's see. This one is going to be half of 1/2, 1/4. That's nice. So this one, what is this one? Let me change its color. So this one is the radius of C2, which is 1, right? So from here to here is 1. So from here to here is the radius of C3. So that's going to be, we just figured out this is 3/4. And this orange part that is left, I'm going to go like this. This is the diameter, which is equal to 2 radius of C4. So is this correct? So can I find the value of R using this? The answer is no, it's wrong, right? Most students will do that. And let me show you why this is wrong. This is wrong because we have to zoom in this part. So I'm going to zoom in and show you the bigger part of what's going on. So C4, the smallest one, imagine it's going to be this. Okay, this is C4, the smallest one. And there will be two triangles, right? C1 and C2, the big ones. Their tangent, I've got to put them really large and big. So they are tangent to this side, right? So this is the tangent point. There is one tangent point here. So you would see that there would be some empty place here. So this place, there is some emptiness. It's not going to touch. So here, this part is empty, not touching. So do you know what it means? What I'm trying to say here is that this 2R, this purple one that you see here, before this one, there is some emptiness here, right? They're not touching. And what is that emptiness? It's going to be this emptiness over here. So they're not touching. You can't use this one, right? Because they're not tangent. The tangent points are not there. They are here. Okay. So what should we do now? Okay. So if I go from here, draw to this tangent point here, that's what we should do instead of that one. So first, is this passing the center? The answer is yes, definitely it is passing that center. And now let's go from here to here. If I draw it like this, now I have my right triangle. Okay. So now let's go and write each one. So again, this small side is 1 over 4. And with the same reasoning, let's go here. So what is from here to here? Like from the green one, this is only 1, right? All of it is 1, but we want this one. We don't want that. This is 1, all of it. We want this part. And this part, the green part, is equal to 1 minus this radius over here. This is 1r, right? So for the green one, I'm going to write 1 minus r. Okay. So again, with the same reasoning, I'm going to go. This is going to be 3 over 4. We just figured this out. And to here is going to be, this is 3 over 4, but we want to go to the center of C4. We want all of this. It's going to be plus 1r. So the radius of this one was D4, 3 over 4, plus a radius. So I'm going to write it better. So the blue one is 3 over 4 plus r. There we go. We made our right triangle. So I'm going to write it like this, 3 over 4 plus r squared plus 1 over 4 squared is equal to 1 minus r squared. And we want the value of r in the question. What is the radius of C4? So no longer we need this diagram, so don't even look at it. We just need to just know a little algebra to be able to find the value of r. So I'm going to expand this. This is going to be 9 over 16 plus r squared plus 3 over 2r. And now the purple one, 1 over 4 squared is 1 over 16, is equal to the green one. Is going to be 1 plus r squared minus 2r. Okay. So we would see, so this r squared will be canceled from both sides, right? We could subtract both sides by r squared. So what will be left? So this 2r, I'm going to add both sides by a 2r here. And this one is going to be 1 minus 1 over 16 minus 9 over 16. So then this side will be 1/2 and 2r. I'm going to write it like this, 3.5r for now. And this is going to be 1 minus 10 over 16, right? Okay, yeah, which is going to be 6 over 16, right? 6 over 16, why did I write it like that? We could simplify both of them by a 2, so I'm going to write them as 3 over 8. Clear it. So 3.5, I'm going to just turn it into a fraction. That's going to be 7 over 2. And the value of r is going to be, so 3 times 2 here, 8 times 7 here. So it will be 6 over 56. Still, we could simplify them by a 2. It's going to be 3. Okay, 28. So the right answer to the problem is going to be this option over here.
Problem 23 is a number theory problem. And like all number theory problems, when you read the question, you have no idea what to do, but you need to do a little trial and error, and then you will figure out a way of how to find the answer. So let's read the problem here, problem 23. If the positive integer c has positive integer divisors a and b, with c is equal to ab, then a and b are said to be complementary divisors of c. So if, for example, you read it, you don't understand, you have to write an example. So for example, if this one is 60, for example, then there are a lot of numbers I could write. So for example, if this is 1, this is 60, right? If the other one is 2, the other one is a 30. What do we call them? We call them complementary divisors of C, in our example, is 60. Now, let's just see what the question wants. Suppose that n is a positive integer, okay, a whole number, that has one complementary pair of divisors that differ by 20. Okay, so for example, like in our example, 60, if it's 1 and 60, then the difference will be 59. If it's 2 and 30, the difference will be 28. If it's 30 and 20, the difference would be 17, right? So now let's keep reading. And another pair of complementary divisors that differ by 23. What is the sum of the digits of n, right? So, right? So n could be like a number that has two divisors. So for example, let's go like this, that the difference is 20. If one of the number is 1, the other number 21 more will be this. Okay, so maybe like this. Or if the first number is 2, 2 plus 20 to 20 will be 22, it will be 44. Okay, if this is 30, it's going to be 23. Okay, so this number would be 69, and it will continue, right? It says now there are two numbers here that the difference is 23. So if, for example, 1 plus 23 is 24, so it will be 24. If this one is 2, 23 more will be 25. This number will be 50. If this number is 3, 23 more will be 26, okay, which will be something 78, okay, and so on. Okay, so now we have to continue this. There is a number that is in both of these categories, right? One way to do this problem is that continue both lists until you find the number that is common on this list, and then we will call it n. Is that a good way? No, because it's going to take a lot of time. So then what to do? Let's write the number n as two equations. We know that if this is the first number a, the other one has to be 20 more. Okay. If n, there's also another number b, and the other number should be 23 more. And when we multiply them, they're going to be the same number. Okay. So can we solve these two equations? No. But we need to write some examples again, right? We have to just go with enough examples so that we figure out a way. So if this one is 10, a plus 20 will be a 30. So n would be 300. Okay. Now, let's see what two numbers will be close to 300. So if I go b is 10, can b be 10? Let's just try this number. If I make this one 10, then b plus 23 will be 33. So this number will be 330. So, you see now, b has to be less than a, right? So that's the key concept here. So if this one is 9, okay, so 3 more than this would be 32. So 32 times 9 is it's a little than 300. So what I'm trying to say here is that the difference here is 20, the difference here is 23. So if they're going to make the same number, b will be 100% less than a. There's no way that b will be more. Okay, so let's just go one example because this is the key concept. If you understand this, then the rest is straightforward. So let's go, for example, for another number. If this one is 15 or if this one is 20, this number will be 40. This number will be 800, right? Can this number be more than 20? Well, if it's 20, then this one will be 43. Of course, this will be 860 more. So we know that, okay, B will be less, right? So if that's the case, if we know B is less, all we have to do is try numbers that are less. So for example, maybe the answer B is only 1 less than A. So I'm going to write this A minus 1, and I'm going to write this A minus 1. If that's the answer, we're lucky. If it's not, then I'm going to write this number as A minus 2, A minus 2. One of them is the answer. We just have to try these. So I'm going to go with this one. Maybe B is only 1 less than A. Okay, let's just try these two values here. So then from the first equation, n is equal to a squared plus 28. Now from this, a minus 1, right? This one was a minus 1. A minus 1 plus 23 is going to be a plus 22. Now let's multiply the second one. It will be a squared, okay, plus 21a, okay, and then it's going to be minus 22, right? I just multiplied these together. So now, because we're talking about the same number, they have to be equal. So both equations, I'm going to write this one, a squared plus 28 is supposed to be a squared plus 21a minus 22. Okay, so from here, we'll see that a squares will be canceled. They're the same. And here, I'm going to write the number here to the left. So I'm going to get 21a minus 20a, okay, is equal to 22. So from here, a is 22. Okay, then let's try the numbers here. We found a number here. We got lucky. If we didn't find an integer, then we would have to change this a minus 2. And then we'll just repeat the process again. So if a is 22, let's just go and plug in that value here. So 22 multiplied by 22 plus 20 is the result for n. So n is equal to 22 multiplied by 42, which is going to be equal to 840 plus 84, right? Which is going to be 924, right? That's the answer. So now you go and try the other numbers. So n is also a minus 1 is 21, okay? And then a minus 1, 21 plus 23, okay, is going to be 44. If you multiply these two values, again, it's going to be 924. So which means we found the number we're looking for. The value of n is going to be 924. We just have to add these digits together, so which would be 15. So the right answer is C. Okay, so let me tell you something general about number theories, okay? So don't think that other students who can or teachers who can answer these questions are like, they read it, then immediately they writing down like some equations and that they find the answer. That's not true, okay? So what they do, they try different values here. They play with the question a little, write different numbers until they figure out a way. So to get this idea that B should be 1 less than A, you have to write a few numbers, okay? So, and then that's how we do number theory problems.
Okay, problem 24 could be very easy or very difficult. It just depends on how you try to approach this question. Now let's start. 6 regular hexagon blocks of side length 1. So here it says that this is 1. And by the way, we know that each side is 1 and each hexagon is made of 6 equilateral triangle. Each one is 60 degrees. This is what we already know. Okay, of a regular hexagon frame, each block lies along an inside edge of the frame and is aligned with two other blocks as shown in the figure. So the question is saying this, like it's all aligned and blah, 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 to say that this line is parallel to this line. So that's why it's saying it. Okay, the distance from any corner, so for example here, to the frame to the nearest vertex of the block. This is a block, by the way, right? This is a vertex or a dot of the block, is 3/7. So it's saying that this side is 3/7. Okay, what is the area of the region inside the frame not occupied by the blocks? So basically, what is the area of these parts together? We have 6 of them again. Okay, and this is 3/7. And here the question also said this is 1. So one thing that makes the question very difficult is actually these fractions, right? So the trick is, let's multiply everything by a 7. Later, once we find the answer, we divide it by a 7, right? We do that. So what we're going to do, if I multiply it here, this will be a 7, and this will be a 3, right? So I made everything 7 times more, right? This one, we changed it to 7. And this is a 3. Now, we know that the blocks are equilateral, so that means this is 7. This is also 7, right? This is also 7. And let's just go and correct like some purple ones here. This is also 3, right? So that means if this is also 3, this is also 3, right? If I go, because they're parallel, right? So that means the one that is remaining here, look, the red one was 7, the purple is 3, so that means this is 4. So this diagram is made of lengths of 3, lengths of 4, and lengths of 7. So let me just go and just draw a bunch more. So this is actually 7. This is actually 4. So from here, the same thing will happen, right? This will also be a 4, right? This will also be a 4, right? We would also know that. Why? Because these lines are all parallel to different lines, right? This line is parallel to this line. This line is parallel to this line. So that means the green one is also 60 degrees. So the green one is also a 4, and a 4, right? So let's go and just draw the parallel lines. If you are, this is red, so this is also red and 7. So this is parallel, this is also a 4. Now I have to draw it green. So this is a 4, and basically that's it. So can you add all these numbers? It's very easy, right? 7 plus 7 plus 4 plus 3 is 21. So that means like the big hexagon, the side of the big hexagon is actually 21. But remember, we made it 7 times more. Like now let's divide it by 7. So it means from here to here, if it's 1, the side of this is 1. Okay, and the big one is actually, the side is actually just a 3. Okay, so the question is getting easier and easier. So how many of these purple ones do we have? If the area of this is A, 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 this is A. What is the area of the big hexagon? Remember, this was 3, and this is 1. The ratio of the sides is 1 to 3. The ratio of the areas is 1 squared to 3 squared. So the ratio of the areas is 1 to 9. If the small one is A, the big one is 9A, right? So the black one, what does the question want? the area of the region inside the frame not occupied by the blocks. So 9A was the big one, minus 6 of these. So we just want 3A. That's the answer. So do you know the area of a hexagon with side 1? If you do know the formula, use it. The question's over for you, right? If you don't know it, just stay with me, right? So it's going to be this, this, and this. Do you know, and we have 6 of this. Do you know the area of equilateral triangle with side 1? If you do, find it, multiply it by 6, you'll have this. If you don't know, then you have to stay with me. So then we have to calculate it. If this is 1 and it's equilateral, I make this height, right? And this would divide it by 2. So this side will be a 1 over 2. And the purple one is equilateral, right? So that means each purple is also 1. So you have to focus on this one. Now, 1 over 2 is squared plus the red one is squared. I'm going to call it height squared is equal to purple one is squared. 1 is squared. So let's just go simplified. 1 over 4 plus h squared is equal to 1. So we're going to get h squared is 3 over 4. So h is going to be root 3 over 2. That's going to be the red side. Now, the area of one of these small equilaterals is going to be this side, 1, multiplied by the height, root 3 over 2, and then we got it divided by 2, right? So the area of one hexagon is root 3 over 4. Now, one hexagon is made of 6 of this, so I multiply it by 6, so it's going to be 3 root 3 over 2. So that is the value of 1A, one hexagon here. So the question we figured it would be like 3 hexagons, so we have to multiply this by another 3, so it will be 27 root 3 over 2. So, no, why did I do it like that? So it's going to be 3 root 3 multiplied by 3. 3 times 3 is actually just 9. So it's going to be 9 root 3 over 2. So the answer to the problem will be option C. So, and remember, like I explained in great detail, if you are good at these ratios, maybe you could answer the problem under 2 minutes, right? It's really not that difficult. Well, the main challenge with problem 25 is knowing what icosahedron, what it is, and what it looks like. If, for example, the question gave us the diagram, then this problem really would be problem 15, 16 difficulty. It wouldn't be really that difficult, right? So the main challenge really is like knowing what this looks like, right? The rest would be much, much, much easier. So in the test, you either know what this looks like, which I think most students don't, but even if you don't know what this looks like, still you're able to do this problem, okay? So I recommend watching the video that I made about problem 18 because I explain things in detail over there, and I'm going to only use what I talked about in problem 18. So it would be a good idea to go and watch it now and then come back and do this problem 25 together. Okay. Okay, now we need to figure out what an icosahedron look like, right? So to be able to do that, we know it's made of 20 equilateral triangles. And what helps us is knowing the Euler's formula. And to know Euler's formula, you just have to visualize a cube or just draw it here. We know that a cube like this has 6 faces. It has how many dots or vertices? It has 8. And it has 12 edges. Okay, so with this one, we know that these two together is 14 minus 2 is this one. So now we figured out the value of this f plus v minus 2 is equal to the number of edges, right? You don't need to memorize the Euler's formula. You just have to visualize it or just draw a cube real quick. And now you got your Euler's formula. So now the question, look, we have 20 faces like this, right? And we want to put them together. Okay, so that means the number of faces will be 20, right? 100%. So the number of edges is easy to find, right? So look, so for example, when we put these 20 together, like this triangle, there would be one triangle here, and there would be one triangle close to it, right? And you see now, each triangle that is joined like this, right? Each of these like edges, okay, it would be a combination of two of these edges. So each two here, okay, when they join, they become one in the octahedron, right? So icosahedron, right? So that's exactly what we're going to do. So how many edges do we have? We know that each triangle has 3. And we have 20 of them here. So here we have 20 times 3 equal 60, right? And now that we're going to join them together here, okay, 2 becomes 1, right? Because they join like this. So the number of edges actually becomes half of this. Each 2 becomes 1, 30. So from here, it would be very easy to find the number of vertices, right? So from this equation, we're going to have the number of vertices is actually 12. Okay, good. So is that enough to know what this actually looks like? No, right? So we got to do it one more time, right? So each triangle has how many vertices or dots, right? 3, 3, 3, 3, 3. We have 20 times 3. So it's going to be 60 points or 60 vertices. Now, this 60 here, they're isolated. When they're joined, they become 12. So that means it was divided by 5. What does that mean? That means our picture, okay, it should be something like this. If I have 1 point here, let me draw a point. If I have 1 point here, then 5 points from 5 different triangles should go this. This is 1. It will be shared by another triangle. It will be shared by another triangle. And it will be shared by another triangle here. And lastly, it would be shared with 5. So 5 points from here, 1, 2, 3, 4, 5, they all become 1 point here because they're joined. So that would definitely help us figure out what it looks like. So there has to be a 5 over here. So that's going to be 5 faces. And because it's going to be symmetrical, we're going to have 5 more here, like opposite to this. So 5 faces here, 5 faces here. Remember, we had 20 faces. So there has to be 10 more faces looking like this, right? So a 5, a 10, and a 5. And that's all you really need to know, okay? So I'm going to, that's the main part. Now the question is a lot easier to deal with. Let's go to the next part of the video. Okay, so far we know that the first layer here is made of 5 triangles, 10 triangles, and 5 more triangles, okay? So that's exactly what we know. And which this shape like will be actually the logo of AOPS, right? Now let's go and actually read the problem. If A and B are vertices of a polyhedron, it's general, it's not talking about this for any like polyhedron. Define the distance DAB to be the minimum number of edges of the polyhedron one must traverse in order to connect A and B. See, it's a little hard. So for example, if it's going to be A could be here and B could be here, why does it say minimum? Minimum would be just go direct. But if without minimum, we could go like this, do, and then go back here. Like it would be infinite ways. Like we could go circle around and go back there. So if A and B is here, it's going to be 1. If I put B here, it could be this one and this one too. And if I put B here, 1, 2, 3. Is there something that could be more than 3? No. So even if I put this one here, see, if I go like this, it will be more. But if I go minimum, 1, 2, 3, that's it. Okay. So, and this is an example that we talked about. So, and now list this part of the question. Let Q or S be randomly chosen distinct vertices of a regular icosahedron. So that means we need to choose 3 random points. Okay, so for example, and I'm going to put them random really, Q, R, S. So what does it say? What is the probability that the distance of Q and R here, for example, Q and R would be here, would be greater than R and S? So this is 1 and 1. So for example, the case I drew, it's not. Okay. So let's just see here. Remember, the numbers we're dealing with, this one maximum could be 3. We talked about it. If this is 3, this one could be 1 or 2. That would be fine. If distance is 2, this one could only be 1. And if this one is 1, then it's impossible, right? Let's go and draw it, for example, here. So because R is common here, I'm going to start by putting R, right? So remember, choosing R is the first point. If I put it here, 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 it doesn't matter because it's symmetrical really, right? This is all the points are the same. So because it's visually easier, I'm going to put R here. It's just for us, not that it changes any part of the question. So now we want Q to be more. So if I put Q here, then QR will be 1. Is it possible to be more than R there? It's not. If this is 1, this number can't be smaller than 1, right? So then if Q is in the first layer, it's not. Okay, no way. So Q has to be one of these points here. So in this layer, we just talked about it. How many points are here? Okay, 5, right? We just did all that work. So they're going to be 5. So what is the chance that Q will be one of this? These two are in the back. One of these 5 points. Okay, what's the chance of that? The Q is in this layer. So how many points or vertices are left? Okay, 12 minus 1. There are 11 points left, 11 vertices. The chance of Q being in this layer will be 5 over 11. So if that happens, this becomes 2. What is the chance that this becomes actually a 1? S. S has to be one of these points here. Again, 5. But 5 from how many points? Remember, 1 Q has already been taken. So R is taken, Q is taken, so there will be 10 left. Plus. Remember, there was also another chance, another possibility that this distance was 3. So for example, I have to clean everything, not R. R was good. So if Q happens to be opposite of there, very unlikely, but it's still possible. So if Q is here, so what is the chance of that happening? So 12 minus R, 11, 1 point. So from this 11, only 1 point. So I'm going to write 1 over 11. And then look, it doesn't matter where Q will go. Everywhere Q goes, it will always be more. So Q goes here, it will be 2, but it's still, sorry, S. It doesn't matter where S goes, right? It doesn't matter where you put S. If we put in this layer, will be 2. If you put RS here, will be 1. So then I'm going to write multiply by how many points are left? Well, 10 points are left, right? R minus Q, 2 are taken. And it doesn't matter where the S goes. S goes anywhere, it will always be less than RQ. So there is a 100% possibility. So all we have to do is just multiply these. So it's going to be 5 times 5, 25 over 110 plus 10 over 110, which will be 35 over 110. Dividing each one by 5, it will be a 7. This would be a 22. And as you see, A would be the right answer.